ABPOL, the Brazilian Association of Polymers. But I'm going to talk about the research projects from Mackenzie, both at the university and at Mac Graphic. And I'll speak about them separately, and I'll explain why I'm going to do that. So here we are. I am the Director of Innovation at ABPOL, hereby representing our president. Let me talk about the Brazilian Association of Polymers. It was founded in 1998. A group of Brazilians that were discussing polymers in Brazil. So they held some conferences. So the idea is to show to you that ABPOL has not been developed for students and teachers and professors, but for the community, for the industry as well, conducting research. We have been renewing in the last few years. We've modernized the association, trying to reach out to all of the sectors connected to polymers, not just the academia, but the industrial sector as well. We were founded in 1988, and here we have the events over time. The Brazilian Conference on Polymers in 1991 in São Paulo, the CBPOL. And then the Polymer magazine was created. We have academic and technical and industrial publications as well. You can have access to the website, you have access to the articles. They're quite interesting papers on polymers, especially with blends and composites. Other important dates here. The creation of the regional offices, ABPOL Northeastern, Southern, Northern regions. So we have been expanding the outreach of ABPOL to the entire scientific community. So here we have CBPOL, biannual congress that happens. The last one was in Joinville last year. It's always in October and November. So the idea is to, we want to generate network and cooperation. So we submit summaries, and this can be published on the ABPOL magazine, but we also have booths, both petrochemical, processing of polymers there. Our visibility increased from national to international. We have received, international speakers. 900 people in the conference. So this covered São Paulo, Rio, Salvador, and Minas Gerais, and it was also, in Paraíba and Rio Grande do Norte. We tried to change and cover many cities, always one in the southeastern region and one outside this region, because our hub is in São Carlos city in the state of São Paulo. Something new to you, our next CBPOL is going to be in 2025 from October 19th to 23rd. I am the president of next year's conference. I am in the overall chair function. The scientific committee is by Professor Denise Petri from the University of São Paulo. So it's not open yet, but the website is going to be open for the registration next week. So you are from the academia, you are from the sector, so you should be there as well. So we have different participations for sponsors with the presentations. We have offers, different types of registrations. This happens very interactively. We have celebrations. It's quite interesting because our cooperation really increases. So here we have the magazine, Polímeros, totally in English. So it has a greater impact now. We use this mechanism that the magazines use. It's quite easy to submit your papers. Please submit your papers and do participate in this magazine, the Brazilian magazine on polymers. So we have been growing. We grew a lot during the pandemic. All of the events had to be online. There are many online courses at ABPOL, courses and mini talks, polymer processing, the one from Marco Aurelio de Paioli, the additives and stabilizing, stress cracking, processing, microplastics, the many courses that happen throughout the year. So please visit our website, the more courses. These are online courses, so it really facilitates to everybody. So we also have a cooperation, an interlab cooperation system. Sometimes the participants want, for example, the fluidity level, they want to measure it. So Mackenzie and Senaki. So we do a round of measures to see if everything is okay, and it's quite interesting. So we see what can be done in terms of maintenance and so many other things. So more or less here, we have the regional offices with ABPOL. So within the regional offices, we operate addressing the science, the academics, industrial part, processing, so that we spread out the information throughout Brazil. With the presence of the regional offices, this is made easier, you know. Some benefits of being a member. We have some discounts for conferences, and even in the online courses that we offer, we can get discounts for the members, and the membership fee is very low. For students, it's 35 BRL. And then we have the prices for professors, and that's an annual fee. So it's worth, you know, becoming a member. You also have discounts when you purchase books. At the CB you can, you know, publicize your brand. You may have your booth as well. You can have, you know, a spot for a presentation within the conference. There are many ways to act as a sponsor. And here we have some of the categories of the sponsors that can take place within the conference. We will soon have a website, and then you will see the amounts and the value for conferences. But in order to be a true member, you can do it right now. You go to abpol.com.br, and then you become a member quite easily. So it's abpol.org.br. We have Facebook, Instagram, LinkedIn, WhatsApp. We have to be everywhere today, or we cannot reach out everybody in a very accessible way. So let me go to the second part. I'm going to talk about the composite research at Mackenzie University with the MAC graph. They're separate here. They're separate here because in the old days, the Graphene and Nanotechnology MAC Graph Institute was right there in an underground level. Today we have different business centers, business hubs. So it's independent from the university. So we, professors at the university, we are part of the faculty at MAC Graphic, but still so, we're separate units. So when I speak about both, there are many things here that are started by the graduate students or post-PhD students, for example. And there are things that I can show, but things that are confidential because they are developed together with companies. So I'm going to show to you some of the projects that have been released for publication. So one thing feeds into the other. Everything that we develop in the graduate course is something that I input in industrial projects. And the industry projects, some packaging companies, some textile companies, they come to us. This really facilitates our life there. Please follow us on social networks. But we have this research group that is registered with the CNPq, Multifunctional Materials. That's the logo. We are on the social networks, publicizing everything that we do in our institute. We have the white papers, the patents, the projects that we do with corporations. Everything is publicized within the research group. But let's talk about nanocomposites. I'm going to show to you some of the things we have been doing. This is part of a bigger presentation I made in Mackenzie University. This really draws our attention, especially for us who work with graphene in the plastic industry. Just to give you an example, we began a long time ago working with this, and at the time, we were not concerned about the graphene quality, but how graphene behaves after being introduced in an extruder after undergoing injection. So first we started using a micro CT scan, just like we do a CT scan of the body to see how health is going. We do that for the polymers, and we can see the distribution of graphene within the material. It's no secret, right? The better distributed it is, the less lumps we have within the plastic, the better the graphene behavior. And we need to use less graphene. We operate with the industrial sector. We know that graphene is expensive. The less we use, the better. But in order to make it happen, we need to really well disperse graphene within the matrix. So let me show to you. So let us show the first video. Polystyrene with graphene oxide at 0.5%. RPM is 250. So we see a good formation of agglomerates. The other, we reduced the percentage, we increased the RPM of the extruder. So you see a crack here, but we see the agglomerates, which are these particles here. Ideally, we shouldn't see anything there, because the CT scan, they are micrometric. They have micrometric sensitivity. If it were fully dispersed, we wouldn't see it. But the dispersion of the material within the polymer is much better. Other examples here using microscopy, electronic microscopy. That's for biomedics. Hydroxyapatite, the skin, and graphene oxide to produce filaments to do the scaffolding for bone growth. Look at this. So we see a ply. The ply is standing there within the polymer matrix. That's what we want to see. We want to fully disperse the graphene plies within the matrix. If we do it really well done, that's how it looks. If things don't work well, we're going to see a lump like this. And that's useless. So we have hydroxyapatite in the other ones. I'm not going to address those. But at Mackenzie University, we try and adjust the extrusion, the blending processes. It's not a preset recipe. We don't do the same for every product. We have to see what kind of polymer we have, what kind of graphene we have, and then we adjust the processes. We, okay, those who are in the industrial sector, they don't pay close attention, but we need to use theory, the calculations, the property forecasting equations. We do it, we use those to see the final results after extrusion, they should be related to the theory. The calculation of the properties should match theory. We do that with the properties of the final material. I would like to show this video as well. So I'm going to show this video as well. I think it's the next one. Tudo bem lá? We simulate the polymer chains. So we have applied, and we see the adhesion of the polymer. In this case, it's a polyamide 1010 with graphene oxide. And then we do the very same simulation with graphene. The binding energy is much lower. So the graphene oxide, because of the chemical groups that we have there, they better interact with the polymer. So we are able to transfer the properties from the graphene oxide to polyamide. It's more effective than with graphene. If we do theoretical tests and simulations, that's better before choosing the processing parameters. So very often they say, I want to work with polymer X on the injection of a bumper in a car, for example. And then we check, is it graphene that is going to solve that issue? Or it's too much? We'll not be able to disperse graphene within the resin. So we take a step back, and then we check what's best for that resin, and then we do the experimental part, okay? There's so many slides. Thermoplastic polyurethane here. That's the TPU tensile curve. We used 0.25% of graphene oxide, but we changed the elements in the thread. The blending elements were replaced by tensile elements. We changed the design of the thread. There are 4 different configurations. Look what I did with TPU, because it would deform up to 200%. I added 0.25 graphene here, and here we have the basic configuration of the extruder, and look how it changed. You went from 200 to 1000% of strain deformation rate, and all I've changed is the screw, the thread configuration. So because of this, we can improve both the tensile properties as abrasion resistance, the friction coefficient. We have different images, we have dispersion, TPU. Watch each element in the thread was performing, so we have all this. And that's a patent that we filed. It's been registered in the United States. So that's for a case in Ohio. Sorry, achei que era urgente. So we had this work with ABS Vision. I couldn't show everything here. It's about to be patented. So the idea was, having more electrical conductivity with the ABS. It could be from anti-static charge dissipation on the surface, but we wanted to have percolation. In order to make graphene generate electrical conductivity, we need the graphene plates to touch each other. We call it percolation. But if you have, graphene that is not high quality and many layers stacked, we're going to need more graphene to do percolation. We want to do it as little as possible. If you check the literature, people can do it at 10%, 15, 5%. And this is totally feasible because it will make the polymer more frail. The piece will get expensive. We were able to percolate here, and it's 10 to the minus 2, which is anti-static property in a polymer. It can be a bit less than 2%. So we adjusted graphene, excellent quality graphene, below 5 plies, 5 layers. And every time you use graphene with more quality, the lowest possible number of layers, the trend for lumping is higher. This is all about hemodynamics. So processing becomes more complicated. So we really have to use the right mix with a very good processing strategy. And then this we can do. It's been more than 10 years working with the extruder, understanding the systems. All systems that emerge, they are a challenge. Things are not linear. So we need working time in the lab. So here, that's the PLA, hydroxyapatite, hydroxygraphene. It is a biomaterial, so we analyzed the molar part, showing that GO improves everything because it makes the polymer more hydrophilic. So the cell expansion is increased. So this work we have been doing with biodegradable polymers. This movie was done by Senai. I took it from them. So we work with a PBAT, that's the EcoFlex by BASF. So we use polyethylene. We call it mulching films. We have been using PBAT, a biodegradable matrix. So we do need some properties for the mulching films. They must block radiation. So we have the coke and the graphene oxide. So we managed to improve the film deformation. It doesn't need to be that resistant. So these movies were done in Sinai. My friends did such movies. Production of films by extrusion. So we measured the transmittance because the mulching film has to block the light at more than 90%. So we improved the mechanical performance, and we made biodegradation tests showing that GO and the coke, they hinder the biodegradation mechanism of PBAT.
So you plant and you collect the plant and you leave your mechanism that it's going to be incorporated to the soil without any toxicity. We are in a phase where we are measuring the toxicity of the soil due to the presence of the polymer, not only the biodegradation rate. Here is another biodegradable PHB. Brazil has been already the owner of the patent. We are the company. It's a polymer obtained by microbiologicals based from sugar with 0.1% of graphene. We were able to improve the impact resistance in traction, tensile strength assays. We can also normalize that. That's the element with graphene that this is with GO. There is graphene. The properties of PHB improve, but what's even better, we don't have meaningful changes in biodegradation. This is the loss of mass based on the days of grounding of this material. This is another project. This is the PLA plus hydroxyapatite. We do this scaffolding. We have already done work in vitro, now in vivo for implants. This was done with Adin Textile, the first partnering company with MacRife, we developed the thread and the fabric with better abrasion resistance. They use it for car seats, for coating. The product was patented. It's called Vitagraphy. It's a project of FINEP. Can you turn on the video, please? What's the most difficult here is to produce the thread. If the graphene is not well dispersed, when I pull the thread in a threader, it pulls extremely fast and the thread may get broken. So we can put the graphene inside, pull the thread. This is at lab scale, but ADM already they do it in their production line. The amount of threads that are pulled, very stable. Then they are texturized, they are twisted. Here our patent with ending, both for processes and products. We have been investing now in Mackenzie in equipment. So we have more equipment in our lab. We'll have a pre-pilot scale. We have extruders that produce 50 kilo an hour, but we are investing now in which extruder, which injection to obtain multi-layered films, multi-layered bottles and equipment, more focus on the product. Here, rubberized materials, the textiles here. Not only in MacRaft, but in our research group, we are very much concerned with environment protection, both in the area of biopolymers and biodegradable, also recycling. So you're all welcome to participate. We always have a connection not only with companies, we are always pursuing technology transfer, but also in our master's and PhD degrees, we have material engineering classes are in the night shift, so we have students that work part-time and develop projects with us, so feel free to ask questions how to access these graduate courses. You are all really welcome. Here I want to thank our FINEP, NCT, CAPES. These are the agencies that support us. This is our last barbecue in the group. So I thank you all for being here. Please follow us on social media because we are constantly updating you on what happens in Mackenzie. Thank you, everyone. Any questions? Any questions? Any comments? Thank you. Thank you.